All right, welcome to week 11. Okay, now I need to find the length of A and B. And it says radicals in simplest form. Okay, so these are my choices. I have Pythagorean theorem, 30, 60, 90, 45, 45, 90, or SOHCAHTOA. Now, all of these require a right triangle. Awesome. Oh my, good. Except not 6, but you are on the right track. Okay, so this is a 30, 60, 90. Correct. So let's draw our parent triangle that you're going to have in your notes. The short leg is A. Oh, use a calculator. Yeah, you are totally on the right track. But there you go. There you go. Okay, the hypotenuse is 2A and the long leg is A rad 3. To go from the hypotenuse to the short leg, I can tell you guys are totally on this. We divide by 2, so we get 9. Awesome. And then short leg. So we're dividing by 2. We're multiplying by rad 3. 9 rad 3. It is all about the short leg, the leg across from the 30. Okay, that is the one. You always go to the short leg first if you don't already have it. Okay, it looks like you guys totally have this one. Notice I could have used SOHCAHTOA, but what would SOHCAHTOA give me that is not according to the directions? Okay, I'm going to be honest. You could use SOHCAHTOA for 9, but why would SOHCAHTOA not give you the answer you're looking for the long leg? There's something in the directions that was the hint that you can't use SOHCAHTOA because it's not going to give you the answer in the correct form. SOHCAHTOA, okay, it didn't say in the directions, but also SOHCAHTOA will only give you decimal answers. It will not give you a radical. So if the directions are saying, it would actually give you the correct answer for B. Yes. Okay. So your clue is that you saw that it had a 60. Okay. But I do have some people just saying, forget it. I don't like the 30, 60. Yeah, the 30 or the 60. There are some people that are rebelling and not wanting to use the 30, 60, 90. And they're like, hey, look at this. I got the right answer. I used SOHCAHTOA and I got 9. Okay. It'll work, but it will not. SOHCAHTOA will not give you a radical answer. Okay. It will only give you a decimal answer. So be very careful to categorize these triangles. Okay. So number 2. Awesome. Okay, good. You know what? The 30, 60, 90, the thing is, with practice, it's not that bad, but you kind of just need to practice. So awesome. Okay. Now, the directions aren't going to say SOHCAHTOA, but let's look at number 2. Let's see if that. Okay. Let's look at number 2 and number 1. Number 2, I have one variable and one side length. Number 1, I also only had one side length. Okay. But number 1, I had a 60 degrees. So I used the 30, 60, 90. Let's talk about let's say I had 2 letters. Okay. So Pythagorean theorem, 30, 60, 90. 45, 45, 90, or SOHCAHTOA. Now, I cannot use Pythagorean theorem because Pythagorean theorem, you must have two side lengths. Okay, I can't use Pythagorean theorem here. 30, 60, 90. I can't use a 30, 60, 90 because my angle measure is not 30 or 60. Yes. Yeah. It's 74. My only choice is SOHCAHTOA. Okay. You're like, yeah. You're so ahead of me. Okay. So I'm not looking for this one. Next is Label. You're so ahead of me. Across from the 90 is the hypotenuse. Now, the 74 can reach its little hand out and touch the X. X is the adjacent side. So let's get rid of all this mess. I've decided on SOHCAHTOA. So if I have adjacent over hypotenuse. Yeah. Okay, awesome. I have adjacent over hypotenuse. Which one is it? Adjacent over hypotenuse. Okay, the number on the bottom is the hypotenuse. Yeah, the 74 really goes in here. X is the adjacent. So am I going to use sine, cosine, or tangent? Yeah, sine, cosine, or tangent. Which one is it? And yes, I will be multiplying. Yeah, sine, cosine, or tangent. Let's see. Adjacent and hypotenuse. Sine is opposite over hypotenuse, not that one. Tangent is opposite over adjacent, not that one. Yeah. Does everyone see why I'm choosing cosine? Yeah. The definition, cosine of an angle, we're going to call the angle theta, is adjacent over hypotenuse. That's what the A and the H mean in, that's right. That's what the A and the H mean in SOHCAHTOA. Adjacent by definition, adjacent over hypotenuse. Okay, so let's write our equation. Cosine of 74 degrees. Oh, you're ahead of me. Yes, awesome. Is adjacent over hypotenuse. Okay, so this is really a decimal. We are going to isolate the variable by multiplying both sides by 13. So X is equal to, so with your calculator, yeah, adjacent is on top. That means we know we're going to multiply. Oh, multiply, right? Not divide. We're going to multiply. Okay. So we are going to multiply 13 times cosine 74. And you should get 3.583. Yeah. Oh, we had to leave. Okay. Round to the nearest 10th. So x is equal to 3.6. Okay, so Katoa. Okay, number 3. Okay, now we are missing, I'm going to put an X here. Now we are missing the angle measure. So this one is a little tricky. Okay, because it looks like it's starting the exact same, but then it changes. Okay. Yes, sometimes they're multiplying. And if the hypotenuse is the X, then you end up dividing. Okay, let's do this one. So Katoa. So we have 16. What is 16? Opposite, adjacent, or hypotenuse? 16 is, yes, that's coming. That is coming. You're ahead of me. 16 is the hypotenuse. 9 is the adjacent. The X can reach out and touch it. Okay, correct. So adjacent and hypotenuse, again, it's not always, but for the second time in a row, cosine. Cosine of the angle is equal to adjacent over hypotenuse. Yeah. Okay. You guys are great. And you're even affirming each other. Nice. You guys are great. Okay. So cosine of an angle is 9/16. So now to work backwards, we need to do the inverse of cosine. Yeah. When the X is the angle. Yeah. You're doing good. When the X is the angle, I need to work backwards to find the angle. All right. So with your calculators, let's practice. Second cosine, and the second gives me cosine inverse of 9/16 equals second cosine 9 divided by 16 equals the measure of angle X is approximately 5.77. Rounded to the nearest degree, the measure of angle X is approximately 56 degrees. Okay, if you're not comfortable with this, you can take 9/16 and change that to a decimal, which is 0.5625. And then you can go second cosine 0.5625, and that'll also give you 5.77. Okay, so we're using inverse cosine. When I had the angle and I want the side, I use cosine. I have the angle, right? When I have the angle, I use cosine. When I want the angle, I have to do the inverse function. So I have to use inverse cosine. Okay, awesome. Okay, so now we're going into area. So what happened here? Oh, well, I think we're good. Okay, stop moving. Okay, now stop moving. Okay, sorry. Find the area. So I need the formula. First of all, what is the name of this shape? Okay, triangle. Yeah. So area of a triangle, what's our formula? Base times height. Yeah, 1/2 base times height. Okay. So okay, sorry. Okay, so 1/2 base times height. Now, the height, how can we determine the height? Let's draw some grass on the ground. Okay, let's draw the blue sky. So the height is the distance from the ground to the blue sky. Okay, now the base is where the triangle touches the grass, only where the triangle touches the grass. Okay, we're not going to use Pythagorean theorem. We're going to use our area formula. Okay, so base. The base is the part where the triangle touches the grass. So the base is 5. The height is the vertical distance from the ground to the sky. So the height is 4.6. So correct. So we have 1/2 5 times 4.6 equals 11.5. Oh, thank you. You gave it to me. Okay. Now, area. Area is like wallpaper. Okay. So it's square units. So it's meters squared. Okay. If it has dots, yeah, but then you wouldn't use this part and you wouldn't use that part. You would have to be, yes, pretend it's a square to see the height, but then don't use the square formula because you'd have to subtract a bunch of parts. Yeah, but I like the way you're envisioning it as a square or a rectangle to help you see the height. All right, number 5. Okay, so let's look at this. This is parallel to this. I have, oh, yay. I have 4 sides. Okay, it's a quadrilateral, 4 sides. And I have 1 pair of parallel sides. 1 parallel and 1 not. 1 parallel pair and 1 not. By the way, that's not 11. That's parallel. Parallel pair. Yeah, parallel. Way too many letters for me to write. Awesome. Correct. Okay, so the name of this is, who can tell me the name? Okay, think about an old movie. Oh, not a rhombus. Good try. Oh no, it's a trap. Yeah. Oh no, you're close. It's a trapezoid. Yeah, trapezoid. Awesome. Okay, so area equals base 1 plus base 2 divided by 2 times the height. Now, this right here may look familiar. In junior high, you learned that this was the average. Yeah, add 2 things and divide by 2. So look at this. 1 base is too big. 1 base is too small. 1 base is too big. 1 base is too small. We're going to average them to get one that's just right. Okay, one's too big, one's too small, and one's just right. Okay, so that's where the formula came from. It's basically finding the average of the big base and the little base. So area equals 3.5 plus 8.9. And we're going to divide that by 2, and then we're going to multiply by the height. Yeah. So 3.5 times plus 8.9 divided by 2. This gives me 6.2. Can you see that this space is too small? This space is too big. Can you see that this one is just right? It is the average. It is the middle between 6.5 and 8.9. Okay, now multiply that by the height. And you get 18.6. Now notice I have, this is meters and this is meters, and meters times meters is meters squared. Yeah, trapezoid, average the bases, multiply by the height. Here's your formula. Number 6. Okay, area of a circle. And we're going to use our calculator to plug in, to substitute for, what is this? Pi. Yeah, like we just had March 15th, 3.14, March 14th, 3.14 day, 3.1415. Happy Pi Day was last week. Okay, area of a circle, pi r squared. Now, this is the last class where you will be plugging in for pi. Starting advanced algebra, if you take advanced algebra, you're going to leave it in terms of pi. So we're going to practice a little bit in terms of pi. So what is the radius? The radius is the distance from the center to the edge. So the radius is 5. Okay, so we're going to start off with the formula. Yeah. And then we're just going to square the 5. Okay. Shh. I'm actually recording this, so you're going to be on the recording. Okay, thanks. Okay, so 5 squared is 25. Yeah, that would be in terms of pi. But sometimes we're going to use a calculator. So 25 times the pi button. 25 times the pi button, you would get 78.539. Yeah, round to the 10th, 78.5. Oh, wait. Area is always yards squared. Oh, thank you. Awesome. Okay, number 7, area of a circle, pi r squared. So the radius is the distance from the center to the edge. What is the radius? Yeah, Zoomers? Even if one person types in, everyone can still type in. Oh, there you are. Radius is 6. Yeah, do we see that the radius is 6? Because that line goes edge to edge, if 12 is the whole distance across, 6 is the distance from the center to the edge. So you have to be really careful where that line is drawn. Okay, so area equals pi 6 squared. Yep. 36 pi would be in terms of pi. Plug it into a calculator using the pi button. 36 times pi is 113.09. Nearest tenth, 113.1. And area is inches squared. Now you can see that right there. If the radius is 6 inches, 6 inches squared, that's where the inches squared comes from squaring the radius. $113.1 inches squared. Okay, area is pi r squared. Circumference. Circumference, the formula is 2 pi r. So 2 times pi times 8 meters. Notice I'm not squaring the radius, I'm just multiplying by 2. So in terms of pi, we have 16 pi meters. Or using the calculator's pi button, 16 times pi $50.265, round to the nearest tenth, 50.3 meters. Notice circumference and perimeter are not units squared. Only area. Area is units squared. Circumference and perimeter are just units, meters. Now, what is circumference? Circumference is a piece of string. So if this is a can, it's just a piece of string around the can. Area would be a piece of paper covering the circle. Circumference is a string around the circle. Okay, number 9, you're going to do on your own. Or you can request it. We'll do it at the end. Okay, area of the sector. Okay. We're getting a lot of movement. Doesn't usually do this. Okay. Area of the sector is the area of a piece of the circle. Okay, not the whole circle. And you can tell which piece because of this little arrow thing right there. Okay, so I don't want the whole circle. I want a fraction of of the circle. Okay, so there's two things we need to know. We need to know the fraction times the area. Okay, so let's talk about degrees. How many degrees all the way around a circle? If you spin all the way around, you have done how much of a circle? You have done like if you spin in a car, you've done how many degrees in a full circle? Anyone know? The 360. Okay, so total is 360. So how is that going to help us find what fraction of the circle we want? Yeah. So the fraction is 300 out of 360 times the area, which is pi r squared. Now, let's go back up here. If the whole circle was 50.3, what if I only wanted half the circle? So if I want half the circle, I would want half of 50.3. Yeah. So to get a portion of the circle, you take the fraction times the entire area, but that was the entire area. So we need fraction times the entire area. So I'm going to reduce this on the calculator. You don't have to. 300 ABC 360. So 300, if you want to use your calculator, ABC 360 gives me 5/6. But you don't have to. You could just leave it as 300 over 360 times pi r. What's r? R is 12 squared. Okay, we're going to plug it into the calculator. So 5/6 times the pi button times 12 squared, which is 144. The area of the sector, which is basically just part of the pi, is 376.99, round to the nearest tenth. This bumps up to 10, which carries over 377.0, rounded to the nearest tenth. Area is always miles squared, square units. Okay, so area of the sector, fraction times total area. So fraction times pi r squared. Yeah, we ready to do another one? Okay, you guys got really quiet. Okay, area of the sector, fraction times pi r squared. Okay, so the fraction is always out of 360. And then I'm going to multiply by pi. And then I'm going to take the radius and square it. You ready? What goes here? Are you there, Zoomers? Ding, ding, ding. 165. Okay, what goes here? $11. Yeah, okay, plug that into a calculator. 165 divided by 360. I'm gonna go ahead and hit the equal sign times pi times 11 squared. Okay, plug it into the calculator. What do you get? Because part of this is not making mistakes on the calculator. Anyone have an answer? You guys still there? Ding, ding, ding. Good. Oh, you used 3.14. Okay. So when I use the pi button, I got 174.227. If you use 3.14, then you got 174.13. I'm going to round this to the nearest tenth, 174.2. And the answer key will allow for a little bit of variation. Okay, but the pi button is better than using 3.14 for pi. A little bit better. Okay, but you would still get full credit for 174.13. That would be fine too. Okay, next. Fraction. Okay, now, technically, yes, I did 165 over 360. For pi, I used the pi button. So I used 3.14159. And you used 3.14. Do you see why our answers are different? Okay, so the next time I see you, we can talk about pi versus pi button. So pi is approximately 3.14. That actually has been rounded. It's actually 14159. It actually goes, no one has ever found the end of pi. Okay, so the pi button has like, I don't know, 10 places out. If you only use 3.14, your answer is going to be a little bit different from mine. So the pi button on the calculator is a little bit better than using 3.14. Or if you want to say 3.14159, there's not going to be any difference because after the 9, it's very negligible. Ding, ding, ding. Yeah. Okay, awesome. But the Canvas quiz will allow for somewhere between 174.13 and 174.22. Nice. Okay, perfect. Okay, let's do this one. Yeah, fraction times, notice here's the arrow telling us which side. Fraction times pi r squared, area of the sector. So we have fraction times area, always out of 360, times pi radius squared. Okay. Oh, Quan, you're the only one left. Everyone's gone. Okay, Quan, what goes up there? All right, 285. And what goes in here? All right, 19. Okay, let's plug it into the calculator. And this time, let's practice using the pi button. 285 divided by 360. At that point, I hit equals, and then I multiply by the pi and multiply by 19 squared. And, oh, there it is. Oh, we only have 2 left. Okay, did you get area of the sector is 897.84? There you go. And we're going to round to the nearest 10th, right? 10th. So area of sector equals 897.8. Yep. Perfect. Awesome. Okay. Last one, right? I think this is the last one. Okay. Fraction times pi r squared. 60 out of 360. Okay, now we need to talk about something. Notice number 10, there was an arrow highlighting the long distance around. 13, there's an arrow highlighting the short distance around. You need to pay attention to this arrow, and it will tell you which side of the circle you need to do. Okay, so 360 divided by 60 times pi 9 squared. And what do you get? Okay, hold on. Okay. Okay, so I was actually looking at something else. 60 divided by 360 equals times pi button times 81. Yes, 42.4. Area sector equals 42.4. Okay, we are done with the toolkit, but I want to look at a problem that you're going to see in this week's quiz. Okay, so 11 CQ, there is a trick problem. It says this is 36 degrees, but this is shaded. Yeah. So, and then this is 10. Okay. So let's do this one. This is going to be for this week's quiz. Area of the sector is fraction times pi r squared. The fraction is always out of 360. Now, how do I get this top number? And I can't see you. Okay. This is tricky. Do you see how tricky this is? Do you see that the top number is not 36? I want the other side of the circle. Yeah. So I'm going to take 360 minus 36. Yeah. To see what I'm doing? Because this is the part I don't want. This is the part that I want. So 360 minus 36 is 324. That goes right there. Yeah, does that make sense? Times pi 10 squared. 324 divided by 360 times pi times 10 squared. And that would give you the answer, which I'm not going to write down here because I want you to do it on your own once you get to the quiz. Okay, that's it. We are done. How you doing? Yeah, any questions? So that last one was not on the toolkit. That was a hint for one of the problems for this week's Canvas quiz. Okay, that is it. We are done. Yeah? Okay, no new work next week. You will hopefully see week 12 show up in the modules, but week 12 is not for next week. Next week is vacation. Week 12 is for the week after, in case you want to get a head start. Okay. End the recording.